I'll draw in next page. Huh? So let me consider a conducting slab, and let there be a beam of light of intensity I and the wavelength lambda. Let it be incident on this conducting slab. So what is this beam of light? It's having a wavelength lambda, then intensity I. Then shall I say that it consists of photons? Now once again, just to have that imagination, I'm showing some shape. We are not sure about that particular shape. So these are the photons. Now what is the energy of all photons will be same. All photons will have same momentum, same energy. And there's a iron rod or iron plate, anything you can take it. Now what is the conductor basically? Contains free electrons and the ions. Ions are fixed and they are vibrating about their mean position. And what about free electrons? They are moving randomly. So this electron, now first what will happen if this particular photon, it will interact with an electron which is present here. Then what that particular photon, as it contains energy, it will go and interact and it will give that. So photon I'll show like this, so that it should be understood for you. This photon will go and interact with the free electron. And what is this dot minus C? It's a free electron. So when this goes and interacts here, so let the photon submit all its energy or deliver all its energy to the electron. So what this electron will do? Will encounter collisions. So it will encounter collisions here. Collision will occur. Then one more collision, or I'll put it like this. It will encounter collisions. Then one more, then one more, then one more. Like this, it will encounter collision. And finally, what happens when it arrives here? It will have energy, say K. This K will be very much less than the work function. So when this electron will come out, only when the kinetic energy of the electron, when it reaches the surface, it must have kinetic energy, it must have energy which is equal to work function. So what is the work function? So we define the work function like this. There is a symbol phi, work function. So when the electron will escape from the surface of a metal, when the energy of the electron, free electron at the free surface, if it is equal to, if it is greater than or equal to work function, then that particular will be electron be ejected from the surface. So it go back to electrostatics. If a charge is binded to a positive charge, negative charge binded to the positive charge, when do it can escape? If you give some sufficient kinetic energy, suppose that there is a positive charge, negative charge. With what kinetic energy I should project so that it will escape to infinity. So there should be equal to interaction potential between that. Similarly, these electrons are binded to the material, to the crystal, to the volume of a conductor by energy called as a work function. See, there are revolving electrons are binded to atom by binding energy. Similarly, the free electrons are binded to the material with an energy called as a work function. If the energy of free electron, when it arrives at the surface, if it is greater than work function, then it will successfully come out greater than or equal. So what I see that this particular K1, it will be less than work function. So therefore, what will happen to that particular electron? This electron 1, I'll call it K1. So as its energy, when it arrives at the free surface of the metal is less than work function. So this electron fails to come out of metal surface. Which electrons will come out? those free electrons whose energy is greater than or equal to work function when it arrives at the free surface, they'll come out successfully. Why that? What is the problem? Shall we say that photon is not given energy as photon gave sufficient energy, which is say 2-3 times of work function. But because of this electron which is there inside the material encounter one collisions, 2, 3, 4, 5. After successive collisions, it has to arrive. It has to arrive. When it arrives at free surface, if energy is less than one function, it fails to come out here. Next, we'll take another set of photon. Which will interact with an electron. This electron, what will happen after absorbing this photon, will encounter collision. Collisions are just shown by star mark like this. And when just it arrives here, it will have energy just equal to work function. So what is the energy of this? I'll say K2, where K2 is equal to work function. Then what happened to this particular electron? What happened? It will just emit out. No, I think I'll write E1. No? Because K I am using for other purpose. So what is the energy of this? Just equal to work function. So then what will happen to this particular electron now? It just drops out of material. Just what happened? It will be available here, no? Just it's available outside the material, that one. So what is the kinetic energy of this? Will be 0. Next, we have another set of photons where they interact with another electron. It will encounter collisions. And here, when it arrives here, it will have kinetic, it will have energy E. It will have energy E, that one. So if you look at that energy E, it is greater than work function. So this particular electron, what happened? There's a third electron, there's a second electron. So if you look at this kinetic energy of this K3, what is K3? K3 should be equal to, it has non-zero. And if you look at the E3, E3 is, we'll put like this. E3 is what will happen? Greater than work function. Then K3 will become non-zero. So this is a third electron. Third electron, what will happen? It will interact with the photon. It will encounter collisions. Then after encounter, when it arrives at free surface, as it's having energy which is greater than work function. So it will eject out with a energy greater than with certain kinetic energy. That I'll call K3. Next, what happens? The photons will interact with some electrons. They will interact with some electrons which are at near the free surface. So there are some electrons there. The photon will interact with. So then immediately what happens? That particular electron will get energy and they'll not encounter any collision. The moment when they interact with the photon, they will get energy. With that energy, what will happen? They'll come out here. So when you look at this particular 4, this E4 will be greater than work function. So when I calculate K4, what all the kinetic energy, what they have? They acquired from the photon, energy given by the photon minus work function. And what is E4? Energy of photon? Sc by lambda. And this is the maximum. So altogether, we are going to get a photo electrons. So what are these? Minus C, ejected photoelectrons. Photoelectron 1, when it arrives at the free surface, it will not have sufficient energy to overcome work function. So what will happen? It will return back into the material and it will lose that energy in the form of heat. Then what about the second electron? It will interact with the photon. It will gain energy from the photon. Then it will encounter collision. By the time it arrives at the free surface, it will have energy E2, which is just equal to work function. So then what is the kinetic energy of this? K2. What is the kinetic energy of this? Will be K2. The next third electron, it will interact with the photon. Then it will acquire energy. It will encounter collisions. By the time it arrives at free surface, its energy will be greater than work function. So it will come out with a kinetic energy, say K3. It will have energy E3, which is greater work function, so will come out. A part of E3 what is utilized to overcome the work function. The remaining what will be available as kinetic energy. Now, if the photons interact with the free electrons which are at surface, then the photon will give all the energy to electron, let's assume. Then the electron open without encountering any collision, a part of energy it will utilize to overcome the work function. The remaining what will be available as the kinetic energy, and this kinetic energy is what will be the maximum, we'll call K4. So tell me like a which photo and the ejected photoelectrons are called as a photoelectrons. I'm making things clear. You get valence electrons, free electrons, photoelectrons. What are photoelectrons? Those which are ejected by a surface. Those which are ejected by a surface. When a light is incident, on a surface, what happens? The photoelectrons are ejected here. Now, what is the kinetic energy of the photoelectrons? The kinetic energy of photoelectrons ranges from 0 to K max. Will I agree? Some photoelectrons which are having 0 kinetic energy will be ejected. That is what K2. There's a minimum, or better say 0. Then some photoelectrons which are ejected with maximum kinetic energy, and that is what SC by lambda minus 5. What is phi? Work function here. So when photoelectron will ejected from the surface, when the photon interacts, when electron interacts with a photon, it will gain energy from photon. Then it will encounter collisions. When it arrives at surface, if the energy is greater than work function, it will get ejected. If the energy is less than work function, it cannot come out of the metal surface. Now what happens if energy equal to work function, just it will drop out and it will be here only, there only. It cannot, what is K2? K2 is 0. The photoelectron will just come out of metal surface and will be there only. What about this electron? Will come out with kinetic energy. What about this? It will, electron 4 will come out with maximum kinetic energy. This what happens here, means all the ejected photoelectrons will not have same kinetic energy. It varies from 0 to K max, and I'm interested in K max. This maximum kinetic energy photoelectron depends on what? Depends upon the energy of photon and the work function. And the work function depends on what? For different materials, work function will be different. Is it okay? So it's not that you should not think like this. When a photon interacts with electron, so what some students are thinking, first it will, I'll subtract energy required for work function, means I'll subtract this. Means here only, once the electron interacts with photon, what happens? I'll remove that energy that is required for work function. Then with remaining energy, it will come. No, not like that. The electron don't know where the surface, it will interact with the photon, then it starts moving randomly. By chance, it encounters a free surface. There, the energy of electron greater than work function, it will get ejected. Less than work function, then it will move back. It will be like this here. So is it all electrons which will interact with photon will be ejected from metal surface? No. Is it all the ejected photoelectrons will have same kinetic energy? No. What are photoelectrons? Those which are ejected due to incident light. When a light is incident on a metal, and when the electrons are ejected, the ejected electrons are called as a photoelectron. Why photo? Because due to light they are being produced. They're being generated here. So they're called photoelectrons. So what is the kinetic energy of photoelectrons? Ranges from 0 to K max. That's what it is telling here. Okay, now we are, sir, what you're discussing, wave nature or particle nature? The photon is energy packet, and electron is a particle. We are talking some sort of like the particle nature of light here, not wave nature of light. So that further I'll explain. So the photoelectric effect, what happened, will not support the wave nature of. That's what finally I wanted to conclude here. Okay, there's a basic idea, there's a core idea which you should have that one. Why 0 to K max? The kinetic energy of photoelectron ranges from 0 to K max. Why 0? Which electron will not encounter any collisions? Those photoelectrons which are ejected by maximum kinetic energy. And which electron has encountered maximum collisions? With those which are ejected by 0 kinetic energy. Because all the photons will have same energy. Sir, what will happen to photon? Why some photon will penetrate more? It depends upon that particular choice of a photon. That means like the photon, sir, why some photons what happen will not interact because the electrons will be moving randomly in their path. If the photon encounters any electron, yes, it will impart that energy to electron. Again, this one. So these photons what happen, they'll penetrate into the material. It's not like only they'll interact on the surface here. They'll penetrate into the material. In their path, if they encounter any electron, they'll transfer that energy. This is what happens here. Okay, let's go for the experiment. The photoelectric effect experiment. This was the scientists earlier prior to 1892. What happened? 96 they observed here. So once after, like they were unable to give explanation anything. Why 0 to k max? Why 0 to k max here? So let's explore other ways. Now, what time the photon means the photon is incident on a metal surface. Then, after what time the electron will get ejected? Instantaneously this is, or will there be any time delay? Okay, let's go back to the classical mechanics, what we know from classical mechanics. So I do have a light source. This is a light source. So at a distance x, I'll keep a surface here. So let's assume that there's a metal. I'll keep some metal surface. Inside that metal, I'll assume a